Hello guys and welcome to Doom 2016 PC game running on two Titan RTX SLI through NVLink bridge and i9-9900K overclock at 5.3 GHz per core, and the cheapest possible DDR4 system RAM, which is 32 gigabytes, 2133 megahertz, but with very aggressive timing. I do not believe in the benefit through the DDR4 frequency when the gameplay in 4K resolution and above, because we're going to utilize less CPU, as well as when the gameplay in 8K resolution, as today I'm going to show it to you. I do not believe at any advantages when you're using high frequency memory of the DDR4 in terms of DDR4 RAM. Okay, maximum, maybe if you're willing to pay 1 FPS for $200, you can go ahead and do it. I am not willing to do so. Maximum advantage from 4000 megahertz will be 1-2 FPS after 4K resolution, and but you're gonna invest about $200 per that FPS. I advise that you go ahead and grab yourself 32 gigabyte cheapest possible DDR4 memory system RAM if you're playing 4K resolution and above, and you will be good. But go ahead and make sure you set the aggressive timing. Aggressive timing sometimes is better than frequency on the DDR4, especially in terms of PC gaming. So during this video, guys, I'm going to show you all kind of different presets. We're going to pretty much play it on 7680 pixels by 4340 pixels, which is 16 divided by 9 aspect ratio, full screen, under the OpenGL API version 4.5. I'm also going to record you guys 8K resolution on a single Titan RTX, but it's going to be a different video because Vulkan API and Doom 2016, even in December or even in January 2020, doesn't support SLI in Doom 2016 PC game. Vulkan doesn't support SLI. So I'm going to show you Vulkan with a single Titan RTX and single Titan RTX and OpenGL as well. I'm going to start with the TI SLI 8xTX. As you can see, everything will be maximum possible visuals, guys. Everything what is maximum possible visuals set to maximum possible visuals, which is nightmare where it's possible. Where it's high is maximum set to high. Okay. Let me real quick go ahead and demonstrate it to you. We're going to start with anti-aliasing all the way up, and then I'm going to play without the anti-aliasing. Can you believe this, guys? But two Titan RTX and SLI is allow us to play Doom 2016 PC game, 8K resolution, very comfortable FPS, totally comfortable status gameplay, and even with the anti-aliasing all the way up. This is just unbelievable. Alright, let's go ahead and get going. I'm going to start the level, which is the arcade mode, the UAC, the first level. As again, the purpose of this video, guys, is not the gameplay. The purpose of this video to show you the data at the right top corner, so we can compare this data with the future GPU architecture, with the future video cards, with the future PC hardware components. Okay, and Titan RTX, guys, and SLI is the first video cards that allow us to play 8K resolution with very comfortable FPS. Keep that in mind. Not only very comfortable FPS, but also comfortable the experience, because we will be able to play Doom 2016 on two Titan XPs or even on two Titan X Maxwell GPU architecture, but the experience at 8K resolution was a little bit slappy, a little bit like a lagging, a little bit like a stuttering feel to it. Right now there is no such a feel to it. It's running so smooth, guys, unbelievable. It's running just like RTX 2080 Ti in 4K resolution, that fast. It's just unbelievable. So it's not a single slack, a single stutter or something like that, single lag. I don't feel anything right now. It's just running such a smooth, guys, experience, and I'm enjoying it. Alright, look like my phone is somebody's calling me on the phone, look like. Sorry about that. We're not about to answer it right now. We're about to do some experiments, 8K resolution with two Titan RTX and SLI through the NVLink. Guys, I'm running it on 8K native resolution screen. Please keep this in mind. So FPS that you see during this video will be the 2 FPS, similar to whatever 8K native resolution screen you have with a similar computer or with the same computer, so keep that in mind. Plus minus 1 FPS, running nice and smooth. Alright, the purpose of this video is not the gameplay or any record setting. So here we go. This was with, guys, you saw the average FPS right here, you saw the latency delay right here, below 10 milliseconds, very comfortable gameplay. You also kept your eye at the GPU utilization, the GPU 1 right now 95%, GPU 2 82%, so I'm not calling it good SLI scalability, but almost good SLI scalability. Good SLI scalability I'm calling about 95% per GPU 1 and GPU 2, 97% very good SLI scalability, and 99-100% I call it amazing, absolutely just incredible SLI scalability when it's 99-100% per GPU 1 and GPU 2. You also keep your eye at the CPU utilization, because today I'm running 6 cores, 6 threads to be able to run 5.3 gigahertz or 5300 megahertz per each core. So basically I avoided all the logical cores and I'm running 6 cores, 6 threads. I disabled the 2 cores in the ASUS Maximus 11 Hero motherboard, BIOS, and I disabled the hyper-threading technologies as well. You also kept your eye at the VRAM usage right here. It wasn't that bad, so pretty much 2 Titan RTXs was, 2 Titan XPs or 2 Titan X Maxwells was be able to run it, because the VRAM almost was like 12.474 megabytes, 12,474 megabytes on Titan X Maxwell GPU architecture, and Titan XPs was the maximum VRAM capacity. But we probably, when we were playing 8K resolution, we probably was storing 400, 500 megabytes into the system RAM, and this is what was creating that little bit of stuttering, a little bit of lag. But right now it was completely without any lag. And also my VRAM today is overclocked. Everything else is running stock. The thermal compound paste on Titans is stock. I didn't replace it yet with liquid metal thermal compound paste, but I'm planning to do so. Completely dual fan design, stock air cooling solution by Nvidia on each Titan RTX. But they were running cooler than 2 RTX 2080 Ti, because there is a 1 slot space between them. When you're running 2 RTX 2080 Ti and SLI, there is no space between them, so they're running much hotter. And my VRAM frequency was overclocked additional about 1600 megahertz, because the Titan RTX VRAM frequency is 14,000 megahertz GDR6 Samsung. Okay, so, and this is 12,345 megabytes is my system RAM utilization right here. Let's go ahead, guys, and disable the anti-aliasing, and let's go ahead and try without the anti-aliasing completely off and 8K resolution. Let's see how well we will improve in terms of the VRAM usage. Is it going to go lower than 12,900, and how well we're going to improve in terms of the FPS if we're going to go ahead and turn down the anti-aliasing. But anti-aliasing in Doom 2016, guys, doesn't. Let me go ahead and restart the level. I really like that beginning at the elevator, because the FPS is stable, so you can compare it with your own FPS. As again, this is arcade mode. The first level, the UAC. But anti-aliasing in Doom 2016 PC game is weak, guys, so I'm pretty sure if Pascal GPU architecture Titan XPs didn't have any issues, I'm pretty sure that Turing GPU architecture not going to have any issues, or even going to show almost no FPS drop. And this is the case, guys. Also, guys, today I'm recording with the ShadowPlay. Please keep in mind, when I'm not recording with the ShadowPlay, please add at least 7-8 FPS, because it's a little bit higher than in regular games when you're recording Doom 2016 PC game with the ShadowPlay technology. So it's about 6-8 FPS, guys, lower when I'm recording, when I'm not recording. So just add about 8 FPS, it will be Gucci. Look at that, it's running so smooth, guys. Without the anti-aliasing, it's completely like, I get the feeling like if you would tell me, okay, you're playing right now on the RTX 2080 Ti in 4K resolution, and even if you're not going to tell me it's OpenGL, if you will tell me it's Vulkan, I would buy it, because it's running so fast. Completely, like Titan XPs and SLI Pascal GPU architecture, guys, was a little bit stuttering, a little bit lagging. and it wasn't that smooth experience. Finally we got, only with two Titan RTXs and SLI it's possible to run Doom 2016 PC game completely, guys. Solid experience, completely comfortable status. It's completely comfortable status, guys. And the latency delay underlying that, as you can see below, 10 milliseconds, completely makes sense. And FPS is right now 75 FPS, so at about 80 FPS, about 88 FPS right now. 80 FPS average, that's beautiful. The VRAM usage is almost 13,000 gigabytes, so we probably was offloading some data from the Titan XPs and SLI when we tried 8K resolution, when I tried 8K resolution over the iPlay4K.com YouTube channel, as well as when I tried with the Titan X Maxwell GPU architecture in 8K resolution. It was the case as well, so we didn't use the healthy VRAM. So we were unloading some data into the system RAM, and system RAM today is clocked at 2133 megahertz, almost as fast as my additional overclock on my VRAM. So whatever you offloading the data, but no matter what is your frequency on your DDR4, whatever you're offloading the data from VRAM into the system RAM due to the driver and Windows operating system AI, so the game is not crashing. It means that guys, you are pretty much going to receive a much slower FPS when you're using just a healthy VRAM without offloading data into the system RAM, and sometimes even stuttering and lagging. Keep that in mind. And I believe this was the case with the two Titan XPs and even with the Titan X Maxwell GPU architecture. But Titan X Maxwell GPU architecture was lagging horribly in 8K resolution, because pretty much it didn't support 4 Titan X Maxwells when I had 4 Titan X Maxwells video cards and SLI in Doom 2016, and I believe only two of them was supported in SLI, and it was horrible. Not only because the GPU CUDA cores was like, you know, almost half that I'm having right now on my Titan RTXs, but it was also in terms of the performance half performance, but at least, and but it was also GPU level second cache was, I believe, 1 megabyte if I'm not mistaken, and the Titan XP's Pascal GPU architecture had 2 megabytes of level second GPU cache, and right now Turing GPU architecture Titan RTX has 6 megabytes of level second cache, or RTX 2080 Ti also has 6 megabytes of level second cache, but it's not enough for RTX 2080 Ti and SLI to run this at 8K resolution, maximum possible runnable resolution, 7K resolution, due to 11 gigabyte of VRAM. Okay, hopefully this makes sense. Or if you somehow you will be able to manage to load 8K resolution on 2 RTX 2080 Ti's, you're probably still going to offload some data from the VRAM into the system RAM, and your FPS will be horrible and probably lagging and stuttering a little bit. So completely ultra, completely maxed out, guys, without the anti-aliasing. Beautiful experience. As again, under the OpenGL 4.5 API, because Vulkan under the Doom 2016 PC game doesn't support SLI even in January 2020. Okay, so right now I'm going to go ahead and switch to ultra preset, then high, and medium, and low. This is the ultra preset, guys. Let's go ahead and have a look if we're going to improve in terms of the FPS. Probably not, because it doesn't give that much you know, in terms of visual, doesn't give that much difference in terms of visual comparison. So I'm pretty sure it's not going to give that much performance in terms of the performance, that much FPS in terms of the performance comparison. But it's nice to see it, and it's nice to see the VRAM usage as well. Probably going to decrease, and immediately decrease to 11,754 megabytes, so below 12 gigabytes of VRAM usage right now at ultra preset 8K resolution. So right now Titan XPs and Titan X Maxwells at least will use the healthy VRAM without offloading the data into the system RAM. Keep that in mind. But still, 2 Titan XPs, guys, at 8K resolution at ultra preset was a little bit stuttering, a little bit lagging. I remember that. And I have that video over the iPlay4K.com YouTube channel. Go ahead and check it out. They also was stuttering a little bit at 7K resolution, not only the 8K, but at 7K resolution as well. Keep that in mind. So, wow, look at that FPS. A lot of actions going on, and I'm dominating over here, and ultra preset pretty much versus everything at Nightmare. What is possible Nightmare, pretty much not a big deal, as you can see, not a big difference, but we still uploaded some data from the VRAM and using less VRAM, as you can see, so it might help with the people with the 12 gigabyte of VRAM that watching this video with the future GPU architectures. If your video card will have 12 gigabyte of VRAM, you still can play Doom at 8K resolution, guys, at Ultra. As you can see, everything at Nightmare will still be overloading a little bit of your VRAM, but Ultra is capable with 12 gigabyte of VRAM video cards, as you can see, and then you will be pretty much holded by the GPU computing performance. Depends how well your GPU will be comparing to Titan RTXs, and if it's going to be great, then you're going to be good, but if not, then it's not going to be good. Alright guys, so yeah, beautiful experience. Latency delay below 10 milliseconds. Are we going to hit at 8K resolution latency delay below 5 milliseconds with OpenGL? I'm just curious, because OpenGL was, guys, way slower than Vulkan, and when I'm going to show you single Titan RTX and 8K resolution, you're not going to believe your eyes the performance that you're going to receive under the Vulkan API. It's just going to be amazing. But unfortunately, Vulkan API doesn't support SLI, but the performance out of the single Titan RTX in Vulkan at 8K resolution will be on another level. So stick around to see that. And yeah, so you saw the FPS, you saw latency delay, VRAM usage was lower than at Nightmare level, and the GPU utilization was almost good. SLI scalability for GPU 1 and GPU 2. CPU utilization under the 6 core 6 threads was below 60%. So as you can see, we only utilize 60% of our cores with the 6 core 6 threads. Completely, guys, makes sense, and just like my other videos. So you can see by this video and by my other videos over the iPlay4k.com YouTube channel or over the iPlay16k.com YouTube channel. Guys, I have a lot of AAA titles recorded at 16K resolution that you don't want to miss over the iPlay4k.com or over the iPlay16k.com YouTube channel. Go ahead and check out those gameplays, 16K resolution on 2 Titan RTXs. But anyways, guys, as you can see, it's beautiful. Let's go ahead, guys, and switch now to medium or to high. Let's go ahead and try high, just in case. Probably not big difference between the ultra and high anyways. Pretty sure ultra and medium will give us some difference, but let's go ahead and try that. So this is the high preset right now. No anti-aliasing, 8K resolution, of course. Guys, I'm coming in real time. English is not my first language, but I'm being PC gamer, PC hardware enthusiast, PC overclocker since 1998 when I built my own computer, 1998, but I was playing PC games before 1998, since 1992. So I have a lot of experience, guys, to share with you. Let me go ahead and start this mission actually from the beginning. And plus, I'm 3D artist, graphics designer, software developer, and hardware system engineers, so I have a lot of experience, guys, from any point of view, any angles. I'm going to provide a lot of valuable information and experience during my videos. Alright, immediately improved, as you can see, 80 FPS right now. I just saw for a second average plus 8 FPS on top of it, guys. Almost 90 FPS right now at high. This is incredible at 8K resolution, running so quick, so fast. But wait till you're going to see the Vulkan API, and then you will tell me, oh my god, too bad that Doom 2016 PC game doesn't support Vulkan API and SLI. Otherwise we will probably hit here 120 FPS, guys. But at the ultra, at the Nightmare actually settings with the 8 times AA, TSSAA, but it would be amazing under Vulkan if it would be supported SLI. But guys, on the single Titan RTX under Vulkan 8K resolution, also playable at comfortable status, because right now I call it comfortable status, even comfortable status of gameplay with the Nightmare level with the 8 times TSSAA. It was the comfortable status, guys. Keep that in mind. Not only playable, but comfortable status. Guys, keep in mind that I'm going to show you 16K resolution, 10K resolution, 12K resolution in Doom 2016 running on two Titan RTXs and SLI. You don't want to miss that as well, because not only two Titan RTXs in SLI allow us to play it as first video cards and Turing GPU architecture as first video cards comfortably with Doom 2016 at comfortable status 8K resolution, but it allows us to play 10K resolution, 12K resolution, and 16K resolution. Of course, I'm not saying that 16K resolution will be comfortable status or even playable status, but it's going to be benchable, testable status, and we want to see it because two Titan RTXs are the first video cards that allow us, guys, to see Doom 2016 in 16K resolution, and we want to see it. We want to see the data, so we can use this data and we can understand the delta, the value of improvements of future GPU architecture, the future video cards, the future PC hardware components. Okay, this is the point of this video. All right, guys. So I showed you this at high preset. You're keeping your eye at the right top. Of course, go ahead and rewind this video, keep your eye at the right top before you're going to start any arguments, because arguments without the facts, guys, going to be pretty much avoided, or I'm going to ban you if you're going to use the bad language and completely be annoying. Okay, so medium preset right now. Okay, and of course medium preset, but of course we're still running 8K without the anti-aliasing. Medium preset. Let's go ahead and have a look, shall we, guys? I'm going to restart the mission. Okay, and let's go ahead and have a look, shall we? Wow, 84, 82, improvement by at least 4 FPS versus the high. At the beginning of the elevator we were like 80 FPS over there average, and right now we 84 when I started, so improvement at least by 4 FPS, which is amazing. Wow, check this out, guys. It's just unbelievable experience. It feels like it's running on Vulkan right now, 4K resolution actually, but it's not. And the latency delay also by about 1 milliseconds faster, showing by about 1-2 milliseconds lower value than it was before, which is faster by about 1-2 milliseconds. Wow, look, just check this out, guys. Just check this out. Oh my goodness. We're just rocking over here at least 75, 76 average, but mostly like I would say 75-80 FPS average right now with the medium preset, and very comfortable gameplay. And don't forget to add 8 FPS without the ShadowPlay recording, and now we're going to be almost 90 FPS average at medium. Wow, at 8K resolution. Can you believe this? And when the SLI utilization is not even good, yes, it is 1.7 probably times faster, around 1.7 times faster than single Titan RTX with OpenGL, but this is what I'm assuming. I didn't see that yet, but guys, I'm going to record single Titan RTX in OpenGL and Vulkan API at 8K resolution just to show you what's up. And don't forget, 10K resolution on two Titan RTXs, 12K resolution and 16K resolution is coming. It's going to be a great videos in Doom 2016. You want to witness it as the first watchers, because nobody before me uploaded to YouTube the videos of 10K, 12K and 16K resolution, because right now I'm running 8K native screen resolution and pretty much you want to have also the hardware capable to pull it. So guys, it's not just just a resolution or something like that. It requires a lot of time, money, energy, nerves and stuff to also to realize when you troubleshooting why it's, let's say, not booting after 8K. So pretty much I'm using 8K native screen and I'm using DSR when I'm going to use 10K, 12K and 16K resolution, but pretty much we're going to render this amount of pixels in real time, and pretty much it's going to be the same performance under the devices that will support natively that type of resolution, such as 12K, 10K, 16K in 2025. But you're going to see, guys, 2025 and 2020 in Doom 2016. You don't want to miss that. Alright, we saw the FPS. Right now I'm going to go ahead and switch to the last preset, which will be, guys, the last preset will be the low. Here we go, and after that I'm going to show you a little bit my PC hardware specification information, and we're going to wrap it up. Let me restart this level real quick. Okay, I just restarted the level. Let's have a look at the FPS, and keep your eye. VRAM usage right now is below 11,000 megabytes, or below 11 gigabytes. Look at this, 87 now, 90, even 103. Wow, 101. We improved by FPS a lot, by about 20 FPS at least, I would say. This is low 8K resolution, and keep in mind the low at 8K resolution and ultra or nightmare doesn't look that bad. We still have beautiful detailed textures because under the 8K resolution we rendering all the texture pixels of that 1024 by 1024 pixel texture. When you're playing 1080p, you only rendering like this little stone at 1080p will be like 100 pixels by 100 pixels. So texture that is covering it 1024 pixels by 1024 pixels, pretty much you're not showing 90% of that texture. Hopefully guys this makes sense, but right now we're rendering completely at 8K resolution the whole experience. If the textures in Doom 2016 4096 by 4092 by 4090, no, I believe 4096 by 4096, which is I have big doubt, to be able to render the whole texture 4096 by 4096 in a 3D object that on a screen that small means that you gotta play at least at 16K resolution, because you're not even going to load the 100% of the texture of that little object, even if you're playing 8K resolution, if you're textured 4096 by 4096. Guys, this is why when you're switching the resolution in your games, you immediately can see additional details, additional amount of visuals improvements. Why? Because why it happens? Because pretty much when you're playing 1080p, you're not loading 90% of your textures. I would say at least 75% of your texture pixel lost of the details if you're playing 1080p for sure, even if the textures is 1024 by 1024 pixels, which is 1080p resolution textures. Okay, and so keep that in mind. So 1080p guys is already Stone Age, and if you're playing, this is I just explained to you a few seconds ago why your gameplay is not pure, because you're losing at least 75% of the pixels only if you're playing like a Half-Life 2 game and 1080p that had the textures 128 pixels by 128 pixels, 256 pixels by 256 pixels. Maybe on 1080p screen you loading completely full amount of the pixels of the textures, as again maybe at 1440p for sure you're loading full amount, but 1080p maybe you're loading 100%. So imagine that, and imagine 1024 pixels by 1024 pixels, you're losing guys 75% at least pixels at 1080p experience. Hopefully guys this makes sense. Guys, it's such a beautiful experience. Below 11,000 megabytes average usage of our VRAM, so below 11 gigabytes as you can see. So pretty much RTX 2080 Ti will be able to render this, or two RTX 2080 Ti's will be able to render 8K resolution at low, as you can see, without the VRAM offloading data to the system RAM. So pretty much with the healthy VRAM usage. Okay, the average FPS was like 93 FPS average, plus you got a 8 FPS, around 100 FPS average at 8K resolution low preset guys. But pretty much everything was so beautiful even at low at 8K resolution, because the amount of the pixels that was rendered throughout those textures, as I just explained to you. Hopefully everything makes sense guys. Right now I'm going to go ahead and switch it to the Windows, and let me go ahead and do that. So let me go ahead and close the game, and I'm going to go to the Windows, and we're going to talk about my specifications. So this is the 6-core 6 threads, completely physical cores guys, utilization right here. I disable the hyper threading technology to avoid any logical cores, and we don't need that, as you can see. Only when your GPU utilization above 92% per each core, the overall the overall CPU utilization, sorry about that, not GPU but CPU, the overall CPU utilization above 92%, average, then means that in that game you need to have at least 2 more additional cores, otherwise you're going to be limited by the FPS. Okay, otherwise you don't need the additional cores, guys. And you saw by my PC gameplays at 8K resolution, 16K resolution, 10K resolution, 12K resolution, the higher resolution after 4K resolution, the low CPU usage actually is used, the low cores is used, and pretty much you're getting advantage only by that CPU frequency. Okay, what else? Let me show you my CPU Z 5300 multiplier for external frequency, which is 5300 megahertz, stable per each core. As again, 2 cores disabled in the BIOS, hyper-threading technology disabled in the BIOS, so 6 cores, 6 threads, 50 multipliers for the AVX instruction, so 5000 megahertz for AVX instruction when you're doing AVX instruction on the CPU, but 5300 megahertz per each core for the total external frequency. The memory is again cheapest possible, DDR4 Corsair Vengeance 32 gigabytes. It's 2133 megahertz, so 1066 megahertz times 2133 megahertz, but very aggressive timing, CL12. And guys, let me tell you, I ran 3D Mark Fire Strike Ultra version 1.1 with the 2 type of memories. I ran with this memory 2133 megahertz CL12, though not CL13 but CL12, very aggressive timing, and it's easy to achieve this timing. You just gotta increase your voltage to 1.35 instead of 1.2, and that's it, it's stable. And I ran it on this computer, and I ran on this computer 4000 megahertz DDR4 at CL18. And believe it or not, that 3D Mark Ultra Fire Strike benchmark, 4K resolution benchmark, scored 25 points more with the DDR 2133 megahertz at CL12 than with the 4000 megahertz CL18. 4000 megahertz CL18 DDR4 scored 25 points less, okay, on the same computer. So as again, aggressive timing is very important in terms of PC gaming. Keep that in mind. 2 Titan RTX for those naysayers, of course, 24 gigabyte per each Titan RTX GDR6 Samsung. Additionally, was overclocked by 1600 megahertz. And let me show you the overclock, and nothing else was overclocked after that point. Here's my overclock, 800 megahertz under the MSI afterburner times 2, 1600 megahertz is our external output frequency on our VRAM. Okay, the GPU was running at stock. Okay guys, here's the comparison. Let me real quick go ahead and show it to you. This is going to be a comparison via disabled 2 cores and hybrid threading technology. Okay, let's take the 7th generation i7 i9 CPU, which has a lot of level 2nd cache and kind of people thinking it's fast, and it has 36 threads. All right, so it's losing by 127 points in single threaded single core performance, and this is very crucial when you're going to multiply it by 6 times. Because as you can see, by 6 times I'm delivering perfectly 3,600 points over here, and this dude with 36 threads, guys, and this is my score with 6 threads, 3,623 as my multi-threaded performance score, and this dude with 36 threads not even delivering 3 times over my 6 threads, but using 36 threads. So imagine that, right? But we dominating a single core performance. So whatever those 6 cores utilized, because in the games he's not going to utilize his 36 threads, guys, but whatever my 6 threads utilize and this very fast 627 performance core, I'm going to deliver my much faster FPS in terms of the output experience in PC games. Alright guys, this dude only going to dominate me in the multi-threaded performance, long kind of benchmarks that you're going to utilize all 36 threads. But as you saw, the game not even fully utilized 6 core CPU, 6 threads. And Doom 2016 8K resolution, 6 core, 6 threads, guys, way to go. 8K resolution and 10K, 12K and 16K resolution that I'm going to show you over the iPlay4K.com YouTube channel or over the iPlay16k.com YouTube channel will also show you even less core utilization. So we're all going to use even less cores at 10k, 12k, and 16k resolutions, guys. All right, hopefully this makes sense completely. What else? Let me show you a little bit on the IDA GPU benchmark under the IDA benchmark version 6.20.5300. As you can see, this is how two Titan RTXs and SLI scored using the OpenCL API versus my Core i9-9900K emulated to i5-9600K with 5.3 gigahertz per core, but the CPU was running 64-bit optimized machine code, guys, and usually CPU doesn't show that high performance in terms versus the GPUs very usually dominating a lot, but just because it was using native 64-bit machine code, this is probably the highest score that this CPU can score. Okay, but you can compare it with your IDA 64 version 6.20.5300 benchmarks to find out how far you're sitting. IDA 64 cache and memory benchmark. Over here you're going to see how fast my DDR4 with this aggressive timing. But guys, let you know that when I'm using CL13 timing that this memory designed for by the XMP, I'm receiving 63-64 nanoseconds latency delay. Right now I'm receiving 58.9 nanoseconds latency delay, at least 3-4 nanoseconds faster, okay, in terms of latency delay, which is nice. With memory, if you're going to have higher frequency DDR4, you're going to have higher figures over here per megabytes per second, and this is only the advantage when you having the long data for a long period, a lot of data passing into your VRAM. The higher frequency will take over and will dominate. But in the games there is no long period, a lot of data passing into your system RAM, only very short communication between the GPU sometimes and CPU stored into the system RAM. And it's very short, it's not the long period of time, and that very short period you better have the aggressive timing, so it's going to happen faster instead of slower, but you're going to pass more megabytes per second. You want to pass less megabyte per second, but kind of a faster pace. Okay, hopefully this makes sense. Then my level 1 cache, level 2 cache, level 3 cache on my CPU overclocked to 5.3 gigahertz or 5300 megahertz per core. Over here the latency delay and gigabytes per second. Go ahead and compare this value with your CPU, even compare this value with your i9-9900K at stock. You will see that I'm going to dominate you in terms of the latency delay, and lower latency delay in terms of nanoseconds is the key, guys, in terms of the FPS. Keep that in mind in PC gaming. Okay, and one more thing I'm going to show you before I will let you go, guys. The very important factor when you're playing 8K resolution and above will be the level second cache on your GPU, and under the Turing GPU architecture in Titan RTX or under the RTX 2080 Ti Turing GPU architecture video cards, there is a second level cache is 6 megabytes, and the second factor will be the VRAM capacity, of course, how much you can store into the frame buffer. And 24 gigabytes, guys, is the excellent amount of data. 32 gigabytes will be the best, but 24 gigabytes is more than enough to play any games at 16K resolution before you're going to overload your VRAM, almost in 99.99% of the games that I tested. So Nvidia knew that, and they gave you 24 gigabytes just in case if you want to push above 8K resolution, and it's just excellent up all the way up to 16K resolution. And they will fully aware of this, guys, just to guarantee you that 8K resolution will be beautiful, guys. And two Titan RTXs, guys, is the first video cards that deliver to us 8K resolution 99.9% of the PC games in 2020, any classic games, and all the way to 2020, guys. Playable with 50-60 FPS average, and very comfortable, or at least playable status experience. Okay. And of course, CUDA cores, 4608 CUDA cores, which is 256 CUDA cores more than single RTX 2080 Ti video card GPU has. Version 6.3 by Nvidia. Revision of this CUDA core is very fast, guys. This is for the computing power. But before that computing power, you want to have a lot of VRAM capacity and a lot of second level cache before you can process that data, compute the data on the GPU. So you'll have ability to store the data. Otherwise, you're going to just overload your VRAM and everything is going to crash. Alright guys, thank you so much for watching. Don't forget to like me with like, to support me and to motivate me to record more great and unique videos. Don't forget to check out 10K, 12K, 16K resolution in Doom 2016 PC game under 2 Titan RTX SLI. It's going to be a great videos over the iPlay16k.com YouTube channel or over the iPlay4k.com YouTube channel. And guys, share it with the friends, subscribe, and check out some great videos that right now I'm putting for you on the screen. If you don't see some great videos, go ahead and check the video description or the comments. It's going to be a great videos for you to check. And have a great day, and I will see you guys till the next time.